Welcome to Gushaga Marina just outside Stockholm in Sweden, where we have been given a world-exclusive opportunity to test what I believe will be one of, if not the most significant new boats of the decade. This is the Candela C-8 electric foiling sports boat. Regular watchers of this channel might have seen a piece I did on the Candela C-7 last year. That was a smaller open bow rider boat. This is a full production version. It costs around about 290,000 euros ex VAT, but crucially it is a bigger, more competent, easier to produce boat. So what do we need to know about it? First of all, it is a full carbon fibre hull, which makes it very light. This whole boat weighs about 1,600 kilograms. It is powered by Candela's own C-Pod engine system, an electric motor that, rather than being an outboard, is actually at the bottom of the rear foil. So it's a bespoke twin motor counter-rotating propeller. It has retractable foils, so in the berth position you can lift them up, or you can use it for crawling around at slow speed in shallow areas. But once you're out on the water, they drop down. They're around about 1.5 meters tall, and that is what gives it the lift and makes it so much more efficient than a conventional planing boat. But we're going to take it out into the archipelago, give it a full demonstration and show you exactly what it can do. We've come out into the Stockholm archipelago on board the very first prototype of the Candela C-8. And I should point out that it is still very much a prototype. There's still quite a lot of exposed machinery. We've got just a plywood cover over the back sun pad, for example. So it's not quite the finished article, but what it should be able to do is give us an impression of what it's like to drive. So we are all good to go. It's a little bit bizarre because there is no idle speed. It's just an electric motor which we switched on. We've put the foils down, and now we're just going to apply some power and hopefully get up to takeoff speed. So line things up, make sure the engine is straight. Again, the foil and the rudder is actually exposed at the moment, but that's going to be covered up on the final version. And let's go. Just hear the motor starting to wind up now. We're at 7 knots, 8 knots, 9 knots, 10, and just beginning to get a little bit of lift, 14, and now we're taking off. And suddenly we are about 2-3 feet above the waves. We've actually got a bit of a wake which we're going through now, but it's flown straight over that. And it's the complete lack of noise and movement that is really eerie if you're not used to it. You're so attuned to the noise of water on the hull and the feeling and the movement as you get pushed around a little bit by the waves. But suddenly when you're up above them, that all disappears. And it's rather odd because we're actually doing 23 knots, but it feels like we're doing about sort of 10 or 11 because all the normal sensations of speed are completely absent. There's no noise, there's no slapping, there's no banging on the hull. We're just gliding over the top of it. All you get is this slight kind of jiggly movement because it's got these automatically adjusting foils. So each of these two side foils are constantly being twisted back and forth a little bit. And the computer works out exactly what's needed to keep the boat flying. So 100 times a second, they are constantly adjusting. And that keeps us level. It makes sure that if we go over a wave, whether that's from the side or front on, it's constantly reading the surface. So there are 10 sensors all around the boat, reading the surface of the waves and adjusting the foils to give you that perfectly smooth ride and make sure that you don't come down hard on one side or go too bow down. And the other thing that's a little bit unusual is that it's a completely flat ride. So normally when you're planing, you're 2-3 degrees, constantly bow up. In this, you're absolutely level. So again, it feels slightly unnerving. It feels almost as if the bow is down a little bit, but it's not. You're just riding level above the waves. So we're doing 23 knots. I can have a perfectly normal conversation. I don't have to raise my voice. I can just hear a slight whir, but the motor on this boat is actually under the water. So compared to the C7, where it was a torpedo motor mounted on a kind of outboard style extended strut, the actual motor of this is on the end of the foil, so it's underwater, which explains why it's quite so quiet. There is a little bit of noise from the adjusting struts at the moment, but again, that's because they're actually exposed rather than sealed. And there's a tiny bit of fine tuning to do to take out some of this little jiggle. So there is a sort of half to 1 foot chop, and it's just pattering over it a little bit, but none of the actual slapping against the hull. And that's particularly with a carbon fiber boat like this that's really stiff. You hear every last noise and splash against the hull, but when you take off, nothing. So we've now put it on sport mode, and that gives us a bit of extra heel. And even though if you turn too quickly, it will dip the hull a little bit, the hull has been designed in such a way that it will just land and take off again. It's like a touch and go on an aeroplane, because it is ultimately still a deep V planing hull, so it will plane. You can retract the foils and it will plane on the hull itself. But obviously it's much more efficient when it is up on the foils flying. So let's have a turn to starboard. You can see it leans in, but we're still on flooring. There's a little touch, you can just hear it as the hull touches the water, because you can hear the noise of the water impacting, but it then takes off again and carries on. So it's not a dramatic situation at all. It's just designed to do that, touch and goes and carries on. But it certainly feels a bit sportier in the sport mode and a little bit more natural. In the standard mode, you just have to be a little bit more gentle and take a nice sweeping turn. What's rather lovely about it is you find yourself adapting to this new style of driving. It's a very relaxing experience because there's no noise and no bashing about. You tend to kind of just chill out yourself and make gentle turns and modest movements, and it's a very different driving experience and a very enjoyable one for it. It's not like an aggressive high-speed sports boat. It's just like a very quiet, comfortable cruiser. A little bit like, I don't know, gliding maybe. You just find yourself relaxing into the experience, taking it easy, enjoying your surroundings, talking to your friends on board. And because of that ride in particular, even if it does get choppy, it doesn't affect you. That only affects the inferior boats that have to stick to the surface of the water. You're a little bit superior, a few feet above them, and quite literally a few feet above the water. There's obviously still some work to do on this boat. There's a lot of tidying and finishing and a little bit of fine tuning. You can hear a little bit of noise as the actuators adjust the foils constantly, but once it's all fitted out, all the noise insulation is in, you can already imagine how calming it's going to be. And because that motor is under the water rather than above it, it's much quieter than the C7. And again, the C7, because it was so much lower, it had an open bow, a lower freeboard, you felt a little bit more exposed and the whole boat felt just a little bit fragile. This is a different experience because we've got a closed bow, we've got a higher freeboard and that deep V planing hull. It's more reassuring. You know that even if you do come off the foils, nothing untoward is going to happen. And once or twice it will do that. You know, if you turn too quickly, it might drop off the foil. Speak of the devil, it's just happened. But as you can see, it's really not anything too alarming. It just comes down off the foils, lands on the hull, and you start again. So how curious did it happen to happen at that precise moment? We'll find out what it is, and again, it's probably something to do with it being a prototype. But nevertheless, it's an interesting demonstration to know that even if it does drop off the foils, it's really no more dramatic than coming over a wave with a little bit of a bang or something. The big question everybody wants to know about electric boats is what kind of range you get. And that's where the Candela C-8 really comes into its own. Because of the foiling system, it is so much more efficient than a standard planing hull. So at the moment, for instance, we're running at 23 knots and we are using just 1.4 kilowatt hours. So relatively speaking, it's absolutely minimal compared to a petrol boat. But what that effectively translates to is that we have already done 23 nautical miles this morning. We've got another at least 15 nautical miles at this kind of speed, at 23 knots. If I reduce it a little bit, we want to stay on the foils. Oh, we've got a couple of boats here, so I'm just going to steer around those now. Just make sure we stay out of the way. But the most efficient speed is usually around about 20 to 24 knots. Again, in the final production version, it'll do 30 knots, but that is actually artificially limited to 30 knots to maintain that speed and range without getting too much power, too much speed, and again, perhaps too much angle. But at the moment, if I just ease it back a little bit, it should stay on the foils down to about 17, 18 knots. We don't want to drop off, but we'll take it down to, so now we're doing 20 knots. And again, it feels almost bizarrely slow at 20 knots because of the lack of any noise or motion. But at 20 knots, we're burning, well, I say burning, I'm so used to the language of a combustion engine, but we're consuming 1.2 kilowatt hours per nautical mile. So that has now extended our range to 17 nautical miles. And you can see how it works. If you can stay on the foils at a nice slow cruising speed, you increase the range. But in total, there should be a comfortable 50 nautical miles in the final production version. And to be honest, in a day boat, that's plenty. I know people get a little bit hung up about the fact that it's only 50 nautical miles and a petrol boat will have a 100-mile range. But the reality is that most of the time you don't start with a full tank in a petrol boat, and you certainly don't burn it until you're empty. In truth, on a day, you're probably only going to be doing 20, 25 nautical miles. And in this, that's very comfortable. Now, one of the other big benefits of the foiling system is that it takes out wakes and waves. So we're just approaching now, there's an old steamer in front of us which is coming towards us, kicking up a bit of a wake. And I'm just going to demonstrate what I mean by that, because if you're in a normal planing boat doing 23, 24 knots, you know about it. On this one, you're aware of it, but not much more than that, just because it rides over the top of it. So here's a steamer, we're just passing on my right-hand side now. We've got a wake about 20 yards in front of us. We're approaching it now at speed, and actually you speed up into it. And here we go, 1, 2, 3, and we're through the wake. That's it. It's as simple as that. There's no banging, no slapping, no being thrown about in the boat. It's just a gentle bob on the foils and you're through. And we're just curling round. We're actually in a bit of a wake at the moment. This we've got a sideways wake. And again, you just heard it probably touch the hull beneath us, but nothing more dramatic than that. And we've got another little powerboat wake here, just going straight through. Gone. Nothing. So even though we're in quite a busy traffic area, we've got wakes from commercial ships, from powerboats, from speedboats. You just glide above it all with little more than a slight bob on the foils. It really is quite a dramatic change from a planing boat. And actually we've got another quite big one here. I can see there's a Beneteau Antares, must be a kind of 36-foot flybridge in front of us. We've just crossed one wake there. We'll go over the next one too. Coming up to it now, it's about 20 yards away. 10 yards. I kind of have to give you the reading because most of the time you won't feel it. And here we are now, through. Didn't even notice it. If you hit that at speed at 25 knots in an 8-meter planing sports boat, you'd probably be close to taking off on it. It's very curious, but I have to say, it's very effective too. Now we've seen the prototype in action, I wanted to show you a little bit more about the construction process and the technology behind the Candela system. So we're now here in the moulding section, and the carbon fibre material is all being cut and hand laid into the mould itself. So you can see the actual fibre is still dry at the moment, it's all being cut and fitted. This will be automated eventually. We're still in the very early prototype factory. they have now built a brand new factory which is all taking shape, and this will be automated. But you can see the carbon fibre material, it is literally material. You can see the fibres here, all being hand laid into the mould. And once that has all been done, it moves to the vacuum infusion process. And it's made in 3 parts. So there is the hull itself, there is the hull stringers which slots into it, and then there is the deck moulding. And this is the deck moulding taking place here. And again, that is all at the laying stage. You can see here is the carbon fibre material itself. This is what makes it so light and so strong. And again, exactly the same thing. It's all being cut and laid into the deck mould. And then the third mould, I don't think we've got an example, but that is the actual stringer system. So that's what provides the rigidity and the strength to the hull itself. And then if we go over here, this was another hull moulding, and this was the one that was being vacuum infused yesterday. So now you can see that the hull itself is in here and it needs to be released, but it has all cured. The vacuum infusion process actually soaks the resin through the carbon fibre material, and when it dries and goes hard, that's what makes it strong. Now then, if we move from this, so that obviously comes out of the mould, the 3 sections get put together, and once they're bonded together, here's the stringer system. So this is what I was talking about. This is the reinforcing stringer system that again is all created as one piece, and that gets inserted into the mould, into the hull itself, and that's what gives it the strength and rigidity. Now we've got a couple of more complete boats here. So this is prototype 2, P2 it's known as, and you can see here you can still see the carbon fibre weave, the actual material in there, but you can hear just how light and dry and solid that is. But underneath it's unfinished. Obviously we've got a gel coat finish on the top sides themselves. But take a look at the technology of the foiling system. So you can see it is a conventional deep V hull with what looks like a step in the hull, but it's much more than a step. It is actually a big cutout. So the reason for that is the foil itself sits on the bottom of these. They haven't got the foil fitted, but these are the struts for the foil. And these are what go up and down through the hull of the boat, so that when it's in foiling mode they come down, but when you come into a berth they retract right up inside there. And actually the whole point is that they lift up above the water level. So on the berth the foil is actually above the level of the water to make sure it doesn't get any fouling on it. But essentially that's what it sits on, and actually to my left hand side, if you look down here, you can see the foil itself. So again, foil, that's what provides the lift, that's what's coming through the water, and that's what's twisted and moved to create that active foiling system. So by adjusting the angle of attack, that creates the lift, and then by twisting it one way and the other, that's what adjusts the actual position and trim in the water. And then if we move further back, you can see there is a conventional step here, so that's a much shallower step, but that just helps release the surface tension and provide 2 planing surfaces, so it will actually plane like a conventional boat at speeds up to about 20 knots if you need to in rough weather. And then if you come under here, you can see the rear foil. Again, that's on an extending strut that goes up and down, and that can sit in 3 different positions. So when it's all the way down, that's when you use it in foiling mode. In planing mode, it's round about this height, and then at berthing mode, it goes all the way up, and again, the whole motor and the foil itself are clear of the water so it doesn't attract any fouling. And this is what drives us. This torpedo-shaped motor, it's missing its end cap and it's missing the 2 propellers, but that is the entire size of the electric motor. So forget these huge diesel combustion engines, that is the electric motor that powers this entire 8.5 metre boat. And it's very clever, there are actually 2 motors in here, one here and one here, and then it has 2 shafts, one of which is hollow, and a solid one which runs through the hollow one, and means you have 2 small counter-rotating propellers on the end of it. So running through this shaft, all you need are the wires providing the power to the motors. There's no shaft running up and down there, it's just wires. And that's what keeps it so thin, so efficient, and then there's 2 direct drive electric motors are what propels this boat up to 30 knots and could do more than that. It's artificially limited to 30 knots, but I find it completely mind-blowing that that is all you need to power a boat of this size and weight. We've come into the workshop to give a better idea of the size and scale of the electric motor, and you can see now that it's got its torpedo cap on the front end. That's what makes it so efficient through the water. But as well as the motor itself, you can see the twin shafts here. You've got the inner one, which is a solid one, and then you've got this outer hollow shaft. So that one is spinning one way, that's spinning the other way, and again that counter-rotating motion gives extra efficiency. It's another sort of 10 to 15%. And then over on this side we can see the rear foil itself. So you can see this beautiful wing-shaped foil, and that's what wraps around the motor. So the motor is actually contained within that foil. And this is the strut itself, and you can see the full length of that. This is what retracts up through the stern of the boat. And then this is the other end of the capping. So the motor goes in there, the foil clamps on the bottom, and that's what creates the drive system. But you can see how long that is. That's got to be the best part of 6 feet long, that rear strut. Very significant piece of kit, but such clever technology. This is another nice little feature which you can choose to specify. Obviously this is an unfinished one, but I just wanted to demonstrate that it has got this folding transom that creates a little bathing platform. And obviously that will be nicer finished, but you get the idea. Not only does it help enclose the cockpit itself, make it a little bit safer and more watertight, it also creates a bathing platform for swimming off. Thoughtful little touch. Now this is what makes the big difference on the C8, because you've got a properly enclosed weekender cabin. Obviously there's an infill that comes in there, but that means you've got a full length bed there. There is even an infill here, so you could perhaps get a small child across the back end of here, but crucially you've got this enclosed space where you can stay warm, you can stay dry. There's a heater for here, you've got lighting. It's actually rather nicely fitted out with this kind of diamond quilted effect. Good quality fabric on the seats. Bit of a hatch over here, that provides the only natural daylight. There aren't any windows in the hull, but you should get enough natural light through there. And then there is this rather nice subtle recessed lighting around it. But crucially, this is what makes it a more usable boat. It's not just the fact that you can stay dry and you can sleep on board. It also gives you a taller freeboard, makes it more robust and more capable of taking a bigger sea. So both in terms of usability, practicality, and crucially how it's built in terms of being made for mass production, it's a better, more usable, more affordable boat. All credit to Candela for giving us access to this very early prototype. There's a lot about it that still has yet to be fine-tuned and sorted, but what it does tell us is that it has the technology and it offers something different. It's not just an alternative to a petrol boat, it's a genuinely different boat that offers a different experience and in many ways a better one in terms of emissions, in terms of quietness, in terms of a soft ride. It is a genuinely different and very enjoyable experience. So while we'll have to wait until we see the finished production version to really give a judgment on value, in terms of the boat itself and the experience it offers, I still believe this is going to be a game-changing boat.